Hey guys, good morning. Welcome to the Theory of Vibration and Aeroelasticity technical lecture series. Welcome to this technical presentation on four major aeroelastic phenomena. One is wing divergence, aileron control reversal, flutter, and buffeting. These are critical topics in aerospace engineering because they directly affect the aircraft safety, controls, and structural integrity. Today, we'll understand these phenomena, comparing them, and study engineering solutions. Now, let us begin. So coming to the wing divergence is a static aeroelastic phenomena that causes torsional instability. It happens when aircraft aerodynamic twisting forces becomes greater than the wing restoring stiffness. Usually this occurs when aerodynamic force centerline ahead of this elastic axis. As flight speed increases, the wing twisting more and more until failure may occur. Key features include time independent behavior, equilibrium based response, critical speed limit, which risks the catastrophic failure. Wing divergence is prevention by increasing torsional rigidity. Now coming to the second component, aileron control reversal is another static aerodynamic problem. Normally, aileron control aircraft's roll motion, but at high speed, wing specificity may cause us bending and twisting, making the aileron produce the opposite rolling effect. Instead of rolling right, the aircraft may roll in the left side. This leads to loss of control effectiveness, dangerous maneuvering condition, speed depends behavior. The modern aircraft wings are designed to avoid aileron speed condition or reversal condition. So, a flutter is one of the most dangerous dynamic aerodynamic phenomena. It is a self-excited vibration caused by the interaction between aerodynamic forces and the structural motion. Usually, flutter occurs due to the coupling between bending and the torsional vibration mode. Beyond critical speed, oscillator grows rapidly. If uncontrolled, flutter can destroy any aircraft structures in a second. This key characteristics use the time dependent oscillatory motion, energy absorption from airflow at high structural risk. Now coming to the fourth one is buffeting is another dynamic aerodynamic phenomena problem, but unlike flutter, it is a forced vibration. It occurs when turbulence, flow separation, wake or gust load excite the structure externally. Example includes tail buffeting bends wings, shock wave buffets at transonic speed, turbulence wake cues the vibration, which cues the time dependent response, no external force source, not self excited, which causes fatigue and discomfort to the structure, which gives the failure. Now, coming to the comparison of the four elastic phenomena, static phenomena, wing divergence gives torsional instability, aileron effectiveness gives the loss of control effectiveness, whereas in the dynamic phenomena, flutter behaves like self-excited vibration, where buffeting gives the forced vibration due to the subturbulence. Static phenomena depends mainly on stiffness, whereas dynamic phenomena depends on mass, damping, stiffness, and airflow interaction in a wing. Now coming to the design thinking phase, the first step is solving elastic phenomena is identifying this the phenomena is occurring due to engineering questions like is the static or dynamic case, is there any oscillatory presence in the aircraft, is it self-excited or external forces created, or the control effectiveness reduced. Correct diagnosis leads to fast and safe engineering solutions and makes the uh, best model which avoiding the aerodynamic issues. The first step is solving aerodynamic problem is identifying when phenomena occur in the engineering, use the solutions, use the is the safe static or dynamic, or the wing bonded or bending or creating a torsional loads, use the inertia or the stiffness of the wing. Once the solutions are proposed, engineering move to modeling and testing. It gives the testing phase, whether the equilibrium analysis or the flutter predict model or the testing like wind tunnels, ground vibration testing, and flight flutter testing. These methods validates aircraft safety before its service. Finally, let us understand the conclusion between wing divergence, aileron reversal, or static aeroelastic problem. Flutter and buffeting are the dynamic aeroelastic problem. Static issues are solved mainly through stiffness improvement. Dynamic issues require damping, control system, and advanced analysis. Understanding this phenomena is essential for aircraft safety, certifications, and high speed performance. So let us understanding these all issues can sort out before it flies. Thank you for your watching. We'll see in the next class.